This is the next part of our DevOps learning series, Web Engines in DevOps. Let's jump right in. Nginx as Reverse Proxy. A reverse proxy is a server that sits between client devices, e.g., browsers, and backend servers. It forwards client requests to the appropriate backend server and then returns the server's response to the client. Nginx is widely used as a reverse proxy due to its performance, flexibility, and ease of configuration. Why use as a reverse proxy? Load balancing. Distribute incoming traffic across multiple backend servers to optimize resource use and improve availability. SSL termination. Handle SSL, TLS encryption, offloading this resource-intensive task from backend servers. Caching. Cache responses from the backend to improve performance and reduce load. Security. Hide the backend server's IP address and protect against direct attacks. Static content delivery. Serve static assets, e.g., images, CSS, JavaScript, while forwarding dynamic requests to backend servers. Failover and high availability. Automatically redirect traffic to healthy servers if one becomes unavailable. Advantages of Nginx as a reverse proxy. Performance. Handles concurrent connections efficiently, ideal for high-traffic environments. Flexibility. Supports diverse configurations for caching, load balancing, and SSL termination. Security. Shields backend servers, implements rate limiting, and blocks malicious traffic. High availability. Offers features like health checks and failover to ensure consistent service. How Nginx reverse proxy works. Client request. A client sends a request to the Nginx server. Nginx processes the request. Nginx inspects the request and determines which backend server to forward it to. Forward to backend. The request is passed to the appropriate backend server, example an app server or database. Response returned. The backend server processes the request and sends the response back to Nginx, which forwards it to the client. Common use cases. Forwarding requests to an application server, e.g., Python Flask, Node.js. Load balancing across multiple backend instances. SSL offloading to reduce backend resource usage. Serving static content and reverse proxying dynamic requests. Enabling caching to improve response times for repeated requests. Example configuration. Here's how you can configure Nginx as a reverse proxy for a backend server running on localhost 8080. Basic reverse proxy. Full configuration block. What each part does. Listen 80. Nginx waits for web requests on port 80, the standard HTTP port. Server name example.com. This tells Nginx to handle requests for your website domain. How the reverse proxy works. Location. This part catches all requests to your site's root URL and sends them to your backend server. Proxy pass localhost 8080. This sends the requests to your backend app running on your server at port 8080. This is common for apps like Node.js, Python Flask, or Java Spring Boot. Think of Nginx as a receptionist who forwards visitors to the right office, your backend app. Keeping important info safe. Proxy set header. Sends the original website name to your backend. Proxy set header x real IP remote ADDR. Sends the real IP address of the visitor. Proxy set header x forwarded for proxy add x forwarded for. Keeps a list of all IP addresses the request passed through. These headers are like name tags, so your backend knows who is visiting and where they came from. Quick summary. This setup listens for traffic on your website domain. Sends requests to your backend app on port 8080. Keeps visitor info safe and clear for your backend. Nginx as load balancer. Load balancing is the process of distributing network traffic across multiple servers. And the software, or hardware, that performs this distribution process is called load balancer. A load balancer is like a traffic cop, standing in front of your servers and routing client requests across all servers. It assures that your application remains operational even if one of the servers goes down. This diagram shows Nginx acting as a * load balancer. Client requests are received by Nginx, which then distributes them across multiple upstream servers, server 01, 02, 03, to balance the load. This ensures better performance, availability, and reliability for handling traffic. Configurations. HTTP block. This wraps the entire configuration for HTTP traffic. Inside it, we define an upstream group, load-balanced backend servers, a server block, front-end listener, upstream my project. These IPs represent application servers, e.g., Node, JS, Flask, etc. Nginx will distribute requests among them using round-robin by default. Server handles incoming requests too. Listens on port 80, HTTP, responds to requests for www.domain.com location, proxy _pass http://myproject. Forwards all requests to the upstream group named. Nginx automatically picks one of the backend servers. Rewrite Nginx. The Nginx rewrite module is used to rewrite URLs based on specific patterns and conditions. This module helps manage URL redirection, improving SEO, and ensuring consistent URL structures. It can be applied to handle requests for non-existent URLs, redirect URLs, or clean up URL structures. Rewrite module. A rewrite is a way to change the URL requested by a client before the request is actually processed by the server. This module helps manage URL redirection, improving SEO, and ensuring consistent URL structures. It can be applied to handle requests for non-existent URLs, redirect URLs, or clean up URL structures. Commonly used to redirect users from old URLs to new ones. Simplify complex URLs for better readability. Examples have been included for your reference. Basic syntax. In Nginx, the rewrite directive is used within the server or location block. The syntax is rewrite regex replacement flag. Regex, a regular expression to match the URL. Replacement, URL to replace the matched one. Flag optional, specifies rewrite behavior. Check the example directive for more understanding. Common flags last. Stops processing the current set of directives and starts a new location search with rewritten URL. Break. Stops processing the current set of rewrite directives within the location block. Remember, regex. Regular expressions can be tricky. Make sure to test your expressions to ensure they match the intended URLs. Order. The order of rewrite rules matters. Nginx processes them sequentially. Apache Tomcat for Java. This article describes the most common ways of deploying a Java web application on Tomcat, including the following: copying web application archive file, .war. Copying unpacked web application directory. Using Tomcat's manager application. Tomcat Application Web Server. Tomcat is a very popular web server, servlet container that can host Java web applications, which are made up of servlets, JSP pages, dynamic content, HTML pages, JavaScript, style sheets, images, static content. Key components. Catalina, the servlet container. Coyote, the HTTP connector that allows Tomcat to communicate with web clients. Jasper, the JSP, Java Server Pages, engine. Tomcat Installation. You install Java and download the Apache Tomcat package from the official website. Then you extract the file, create a Tomcat directory, and move the extracted files into it. Finally, you set permissions, ownership for the Tomcat folder and edit the Tomcat users.xml file for user configuration. Requirements. Java 10 or higher. Java WAR file. Ubuntu 20 or higher. Root, sudo privileges. Nginx, as reverse proxy. Here's how to properly insert the Tomcat users block into your conference/tomcat-users.xml file to define roles and users for accessing the Tomcat manager and admin interfaces. Replace strong password with a secure password of your choice. This configuration enables manager user to access only the manager GUI. Admin user to access both the manager and admin GUIs. Location. Ensure this is placed in /op/tomcat/conf/tomcat-users.xml or wherever your Tomcat installation resides. Creating a system service for Tomcat. Step 1. Create the service file. Step 2. Insert the service. Explanation. Unit. Description. A short label for the service. After network target. Ensures Tomcat starts after the network is ready. Service. Type equals forking. Tomcat forks into the background. Systemd expects this. User group runs Tomcat as root, can be changed to a safer user. Environment sets Java and Tomcat environment variables. Exec start, exec stop points to Tomcat's startup and shutdown scripts. Install wanted by equals multi-user. Target makes Tomcat start on boot in multi-user mode. Step 3. Reload and start the service. Step 4. Verify status sudo systemctl status Tomcat. You should see Tomcat running and active. A reverse proxy server is an intermediate connection point positioned at a network's edge. It receives initial HTTP connection requests, acting like the actual endpoint. Proxy passcode for Nginx. Directive by directive explanation. Targets requests on your domain. Nginx will apply the following proxy rules only to this path. Reverse proxy logic. Forwards requests to the backend server running on port 8080. The path is preserved and passed to the backend. Buffering control. Disables response buffering. Useful for real-time applications like streaming or live logs. Preserving client info with headers. Sends the actual client IP to the backend. Passes the original header, e.g. tells the backend which port the client used, usually 80 or 443. These headers help your backend understand who the client is and how they reached you. Thank you for your attention. Subscribe to our channel and never miss a weekly tech episode.